AV4-3 is all about calculating the volume of a cone. If you haven't already, go ahead and watch the video that's posted just above this one, that visual proof of the formula, and then we'll talk about it. Alright, so if you watch that video, you can watch them fill up a cylinder with 3 conefuls, for lack of a better term, where the cone has the same radius and the same height as the cylinder. So that proves to us that a cone is 1/3 the volume of a cylinder with the same radius and the same height as the cone. Remember that the cylinder was pi r squared h. So if I put that all together, I get this formula, 1/3 pi r squared h, where the area of my base is a circle, just like it was in my cylinder. So the pi r squared h comes from the circular base, h is my height, third is because it's a cone. Right, so using that formula, and again this formula works for oblique cones and right cones, I can use that formula to say my volume is 1/3 pi r squared h, and I can plug everything in. So I have 1/3 times pi times my radius 3 squared times 10, which means I have 1/3 times 9 times 10 times pi. I'm going to throw these both over 1, and then I'm going to do the good as gold thing. If you don't remember that, all I'm doing is I'm saying, hey, both 9 and 3 are kitty corner from each other. They're both divisible by 3, so let's divide it now just to make life a little bit easier. And now I'm doing 3 times 10 pi, and I get 30 pi. Again, we're not touching our pi button. We're not using 3.14 unless we're specifically told to. On our right cone, we're told our volume is 24 pi, and we know our radius. We're looking for the height. So I'm still starting with my formula, 1/3 pi r squared h. I'm going to plug in everything I know. So I have 24 pi as my volume. My third and my pi are constants. My radius is 2, and I have my height. So I have 24 pi is 4/3, because 2 squared is 4 times 1/3 is 4/3 pi times my height. I'm first going to clear my fractions, and what that means is I'm going to multiply both sides by 3 so that drops out. This side becomes 4 pi h. 24 times 3 is 72 pi. Now I can divide both sides by 4 pi. My pi's drop out. And I get 18 equals my height. All right, on this last one, we're asked to find the volume of the cylinder with the cone removed. I have a choice here. I can do it one of 2 ways. I can either start by thinking of it as area of my volume of my cylinder. Find that, find the volume of my cone, and then subtract them both. I could do the entire formula, right? I can do pi r squared h minus 1/3 pi r squared h, solve for both, and then subtract my final answers way down here. That's not wrong. You can do it that way. I could also try to generate a formula and then only have to plug in numbers once. So taking just this line right over here and rewriting it, I'm doing pi r squared h minus 1/3 pi r squared h. If I think of pi r squared h kind of as a variable, this is kind of like saying, let's do 1x minus 1/3 x. Well, gee, that has to be 2/3 x. The only difference is, instead of x, I'm using pi r squared h. So instead of thinking of it as, hey, let's do an entire cylinder, solve for that volume, find the entire volume of the cone, subtract them, I could also say, well, really I'm only keeping 2/3 of my cylinder because I'm taking 1/3 of it away. Right? And this idea helps me visualize that. So I'm going to go ahead and solve that way. So I have 2/3 times pi times my radius, 10 squared times 15. So I have 2/3 times 100 times 15 times pi. Again, I'm going to do the good as gold thing. My 15 and my 3 are both divisible by 3. So I get 1,000 pi. And again, if I really wanted to, I could find the entire volume of my cylinder, right? I could do 100 times 15 pi or 1,500 pi. I could do 1/3 times 100 times 15 pi, which cleans up to 500 pi. And if I subtract those, I still get 1,000 pi. Right? So it's not wrong to do the entire volume of the cylinder, the entire volume of the cone, and subtract the answers. But it's also not wrong to say, gee, I only am keeping 2/3. Let's just use this formula.